Geoprober is a deep-water exploration drilling system deployed from a monohull vessel. The company is designing, building and testing proprietary surface and subsea drilling technology that will reduce drilling costs by at least 50%. Geoprober is a joint industry project funded by Chevron and Statoil Hydro. Geoprober is a slim find-a-well system using 7 5/8 casing as the riser and the drilled-in surface casing. The shut-off system is deployed to the seafloor through the vessel moonpool on the casing. The vessel must also have an adequate riser tensioning system installed on the main deck around the moonpool. At the top end of the high-pressure casing riser is a near-surface BOP, which is positioned below the keel level of the vessel. It is connected to the vessel deck with a high-pressure slip joint. At the seafloor is the Geoprober shut-off system, or GeoSOS, a combined casing hanger wellhead and an emergency disconnection mechanism. The Geoprober system is designed for deep-water prospects where the potential reservoirs are at a relatively shallow depth below the mudline. For example, in West Africa, Brazil, India, and the Far East. As the chart on the lower left shows, with the Geoprober system, exploration budgets can be stretched further and additional prospects drilled in expensive deep-water areas. This advantage must be weighed against the current technical limitation of slim logging and sampling tools. However, the range and capability of these tools is advancing rapidly. As this comparison shows, the Geoprober slim well design and reduced weight of the subsea shut-off system results in a large reduction in the weight of casing, volume of mud and cement used, as well as fuel consumption. This not only provides economic benefits, but also a much lower environmental impact. The simplified well design also reduces the well planning lead time. By drilling in the surface casing, cementing it in place, and converting it into a riser, large time savings are possible compared with a conventional deep-water rig. The purpose-designed handling system means that coiled tubing can be rigged up very rapidly and spooled into the well, reducing the trip times through the water. The calculated cost savings for this example well are 59%. Let's follow the installation sequence of the equipment. First, on the drilling vessel, the conductor is connected to the template in the vessel moonpool. Separately and offline, the casing joint with the 9 7/8 drill shoe is inserted into the Geoprober shut-off system and gripped. The shut-off system is picked up on the casing and then connected to the template using an external ball gripper. The entire assembly is lowered to the seafloor on the 7 5/8 casing riser. The control system enables the package to be jetted into the seafloor using instrumentation to ensure the verticality of the conductor and also to indicate soil reaction on the template. After jetting, when the soil regenerates its strength, the running gripper can be released and casing drilling can start straight away. The Weatherford drill shoe is used to drill to the surface casing setting depth. When TD is reached, the drill string is pulled back, the near-surface BOP is installed, and the casing suspended on the grippers at the sea floor. Prior to cementing, a setting ball is dropped, enabling the cutters to be extruded parallel to the casing wall. After waiting on cement, drilling can continue in the next hole size with a coiled tubing BHA. As an alternative to the Weatherford drill shoe, the Tesco system provides formation evaluation if required in the surface hole. Let's now look at the main achievements of the joint industry project. In Phase 1, this included the design, build and test of the prototype lower Geoprober subsea shut-off system. The critical wellbore seals were tested to the required 7,500 psi under cyclic loads. The grippers were tested with a casing load of 120 tons and torsion tested to casing make-up torque plus 50%. Phase 1 also included casing and drill string shearing tests. Later, in Phase 1A, the annular cutting tool was developed based upon radially driven, high-strength cutting wheels rotating inside of the lower shut-off system. This provides a routine disconnection of the casing riser, resulting in a clean radial cut. Also in Phase 1A, fibre optic strain gauges were developed to remotely measure the stress on the casing riser at the re-entry hub. An important milestone was the development of the prototype subsea control pods, designed for operations in 3,000 meters of water depth. And now to the future. During the construction of the system, the company will further develop its operating capability. Close cooperation and planning with the vessel contractors, such as ACA, Island Offshore and TS Marine, will ensure the complete slim well system can be deployed from a variety of vessels. A program of commitment exploration wells would underpin the business and secure a target vessel under charter contract. It would enable the naval architects and certifying bodies to prepare the vessel safety case and the certification of the equipment. In all these activities, Geoprober Drilling seeks to develop a deep water exploration system that reduces the overall cost of exploration by more than 50% compared with a conventional well. This will be achieved without compromising safety, environmental protection, or the value of the data obtained.